Hugging Face makes it simple for us to work with PyTorch and TensorFlow workflows. This is useful when integrating large language models into existing machine learning solutions you may already have. And it allows us a method for fine-tuning any models. Here we will introduce how to start working with Hugging Face and PyTorch. If you'd like to work with TensorFlow, the code is very much the same. You'll just want to use the TensorFlow specific classes. Usually these are just the same class names with TF added to the name. So from transformers we want to import the pipeline, auto tokenizer, and the auto model for sequence classification. We'll also import the torch package. We already have our sentence and our input IDs from earlier, so let's print these out and refresh our memory. To get our output in the correct format for PyTorch, we need to specify we want the input embeddings to be returned as tensors. Let's update our tokenizer for this. So we'll create our tokenizer and then use autotokenizer.fromPretrained and specify the model we're going to use. This is a fine-tuned model from the Hugging Face models page that can classify text as positive or negative. We'll then create input IDs PT, and we'll use our tokenizer over our sentence, and we want to specify return tensors equals PT. This will return our input IDs as a PyTorch tensor. We can print these out to check it has worked. And yes, you can see the output is the same, but it's now formatted within a PyTorch tensor. Let's now create our model. So we'll use auto model for sequence classification, .from pretrained, and again we'll specify our model. We're now ready to use PyTorch on our inputs to do some inference of our own. So with torch.nograd, we obtain the logits by running the model over our input IDs PT. We then want to return the label of positive or negative for our input text. So we'll get our predicted class ID, and to use this we'll take argmax.item and then we take our model.config.id to label of this predicted class ID. This is essentially looking at the dictionary mapping of the numeric scores to the classification labels. So it's looking to see whether it should return positive or negative. And once this is printed, we can see it's been returned as positive. So let's see what our sentence was. I'm so excited to be learning about large language models. So yes, a positive classification seems appropriate here. These steps are essentially what is happening under the hood when we use the pipeline function. But being able to work with PyTorch, TensorFlow, and Hugging Face together in this way means we have so many options to customize our models and understand what is happening when we use more abstract methods such as the pipeline.